Hi. Hello. Am I audible? Andariki. Hey, I'm really sorry, Ray. Due to a technical reason, we had to, end this session. Kani, we're good to go now, right? Andariki, all of you, Kasari. Tell me. Chalo, shall we start? Great. Okay, Nandini, let's start. All of you are there? Attendance is very low, 8 people. Start చేద్దాం. Good. People are increasing. 14 now. Hello. Chalo. So let's start about units and dimensions. So students, to understand units and dimensions, నాకు ఫిజికల్ క్వాంటిటీస్ గురించి కొంచెం ఐడియా ఉండాలి. సో వాట్ ఆర్ ఫిజికల్ క్వాంటిటీస్, సర్జీ? See, is it working now, right? సో ఏంటి సార్ ఫిజికల్ క్వాంటిటీస్ అంటే? ఫిజికల్ క్వాంటిటీస్ ఆర్ ద క్వాంటిటీస్ విచ్ can be measured definitely. Hello, mic testing, 1 2 3. Chalo. Physical quantities are the quantities that could be measured. But the handwriting is not coming good, Ray, in this. So let's start with the example, okay? Andariki, what is the attendance? 24 only, Ray. 24. Chalo. Yeah. So read these statements, students. I ate 20. What 20? Em tinnanu. His weight is 60. 60 what? Samir walked for 500. 500 what? Enti. The information here is incomplete kada. Endukante we did not specify the units over here. So for instance, someone might say that I ate 20 elephants. Appa. His weight is 60 quintals. And Samir walked for 500 miles. Are you understanding the situation is real? Unreal? Okay, 500 kilometers. Good. So this decides the intensity of statement that I am telling. Okay. So let's correct it. Correct cheddam. So to correct it, okay sir, no. I did not eat 20 elephants. And then 20 grapes tinnanu. Here also his weight is only 60 kg, sir G. And here also Samir only walked 500 steps. Students, to measure physical quantities, we need the units kada. So units is the game of units. You change it, you will change everything. Ardham vastundi kada? Good. Chalo. So students, మా దగ్గర రెండు రకాల physical quantities ఉంటుంది. The first type of physical quantities that we have is a fundamental physical quantity. The second type of quantity we have The second type of quantity we have is a derived physical quantity. So we have two types of physical quantities. One is fundamental, the second one is derived. So sir, fundamental enti ante, there is this definition: the quantities that are independent of each other and exist independently. There are only 7 physical quantities that could be categorized into fundamental physical quantities. You remember this. Gurtupetkovale, there are only 7 physical quantities: mass, length, time, amount of substance, actually you can say mole also, current, the rate of flow of charge, current. Next is temperature, and the last is luminous intensity. ఇదే నా 7 physical quantities. ఎవరైనా ఇప్పుడైనా if someone asks you what are the physical quantities that are fundamental, so here you must say, Sarji, there are only 7 physical quantities that could be categorized as fundamental physical quantities. Okay sir, అర్థమైంది. So let's talk about the units of them. So length గురించి మాట్లాడితే the fundamental unit is length and the unit of length is meters. We also have two types of units, students. The first one is the SI unit, the second one is the CGS unit కదా. So here నేను SI unit గురించి మాట్లాడుతున్నా. So I'm only talking about SI unit over here. SI అంటే international standards. Arey sir, if the international standard is the name, why not IS ray? Why only SI ray? International standard units, and this is centimeter, gram and second units. You just remember the short form, okay? So for length SI unit is meter, for mass it is kilogram. Okay sir, the time is second, electric current is ampere, temperature Kelvin, amount of substance mole. Luminous intensity ante entira? What is luminous intensity? It is not asked much for you. Can you just remember the unit of luminous intensity is candela. సరే సర్జీ, ఇప్పుడు derived quantity గురించి మాట్లాడతాం. What are the derived quantities? Observe చేయండి. The quantities that are derived from the fundamental physical quantities could be categorized into the derived physical quantities. The example for this is velocity. Sir, what would I write for velocity? Em ravale. So you can simply say velocity is equals to distance upon time kada. So sir, distance ante length, and length is a physical quantity, that is a basic physical quantity, right? Fundamental physical quantity. So you can simply say length upon time. అర్థం వస్తుంది. Here also force, sir. What is force? What is force? What is force? Force is equals to mass into acceleration kada. Mass is a fundamental physical quantity, కానీ acceleration కాదు. So what can we write about acceleration, sir? Acceleration is equals to speed upon time kada, delta v upon delta t. Speed ke unit ఇప్పుడే చూసావు కదా. So speed is length by time divided by time kada. So acceleration could be written as length upon time ki square. So ekkad nunchi come back to the expression of force, what you will get is force is equals to mass into acceleration. Acceleration entira L upon t square kada, ante. So this force is a derived physical quantity, and we chose 3 different base fundamental quantities to derive force: mass, length, time. So once you relate these fundamental physical quantities, you will be getting your derived physical quantities. And this, sir, I have also calculated about acceleration. What about area, right? What can you say about area? How would you derive area from fundamentals? How would you derive area? How would you derive area? Sir, G, area is equals to area of square గురించి మాట్లాడతాం. So if at all నా దగ్గర ఒక స్క్వేర్ ఉంటే length is L, length is L. So area of a square is equals to length square. Length is a fundamental physical quantity, so area is equals to L square. So here also we have derived the formula for the area kada. Good. So students, for any physical quantity, I can write the measurement of that physical quantity in two different ways. The first one is its value, and the second one is its units. Sarji, how would you write it? So for example, let's say I'm talking about weight. So weight ni ela ravali ante, you first write the value. What is your weight rate? 60. Okay, 60 what? 60 tons, 60 quintals, 60 what? 60 kg kada. So this is my number n, and ide na unit u. Ardham vastundi kada, all of you. Here also, when you talk about, let's say, the length, what would you talk about the length? The length is 10 meters kada. So ekkada 10 is your n and m is your unit. So the first one is the value and the second one is the unit of value, whatever you are talking about. Okay. So for example, let's move to the next slide. Yeah. So talking about the units, Sarji, what is the unit? What is the unit? What is the unit? Okay, for example, I am telling you, I ate 60 what? Eggs. So ఇదే నా యూనిట్ కదా. Eggs is also a unit. అర్థం వస్తుంది. Okay. So no, not I will not eat it. So let's say he ate 100 slaps. Slaps is also a unit kada. అర్థం వస్తుంది. Okay, Sarji. He wore 10 rings. So rings is also a unit kada. You can say that. So here n is 10, n is 100, n is 60, and these are all the units of measurements. So units kuda, there are two types of the units. Rendu rakalu unnai. The first one is the SI units, Standard International Units. And the second one is CGS units. Students, keep this in your mind. When we talk about SI units, we are only concerned about the standard units that we will be using throughout your 2-year journey. So if I am talking about current, SI unit is going to be ampere. And if I am talking about, let's say, energy, what is the SI unit? What is the SI unit for energy? The SI unit for energy is joule kada. Good. So these are the definitions of units. So units ki characteristics emuntayante, you have to remember this. The first thing is that the unit must be universally accepted. You are talking about, sir, I have this much of length. What do you mean by this much of length? This length of my hand kada. So my hand is different, your hand is different. How would you consider this as a unit? So let's say, sir, I have to calculate the length of this board. So this is 1 hand and this is 1.5 hands. 2 hands of unit is there. Not valid kada. Why? Because when you talk about units, it must be universally accepted. The second property of unit is that it must be fixed and well defined. So unit must be fixed. So if I'm talking about this much of unit, you should not change this unit. We will use it throughout our entire life. The third is the unit must be of suitable size and easily available. You are telling that, sir, 1 meter is this much kada. So this is 1 meters. And then you suddenly say, no, sir, I don't want 1 meter. I want 1 kilometer of unit. How would you get 1 kilometer all the times? You can't get it, right? Chalo. So observe cheyandi. These are the 3 basic properties of units. First one, it must be universally accepted. Second one is it must be fixed and well defined. And the third one is it must be of suitable size and easily available. Ante. Next. Let's compare the SI unit and CGS unit. Students, my champions, keep this in your mind. Whenever we are talking about the length, what is the SI unit? SI unit is meter. And remember, 99% of the cases, whatever questions I am going to solve, I must make sure that all units are in the SI system only. SI system lo units unte I will touch the question, or else I will not touch the question. I will convert this SI units into CGS or CGS to SI. Okay, sir, length ki SI unit ante meter untundi and length ki CGS unit ante centimeter. Relation enti adda? What is the relation? The relation is 1 meter is equals to 100 centimeter. Good. ఇప్పుడు మాస్ కి SI యూనిట్ అంటే కిలోగ్రామ్ కదా, అండ్ CGS యూనిట్ ఇస్ గ్రామ్. ఏంటి రిలేషన్? 1 kg is equals to 1000 grams. Similarly, come here, time ki unit SI కూడా సేమ్, CGS కూడా సేమ్. Let's talk about electric current. The SI unit is ampere, the CGS is biot. Ekkada, you just observe students because it is a twist. Endukante 1 ampere is equals to 0.1 biot or BI you can say. Temperature ki unit kuda same undi Kelvin. Amount of substance is also same and intensity is also same. So ide the three observations that I have to remember: length, mass, current. Ante. Next, now that we talked about the units, students, I want you to attempt this question. Convert the area of 5 meters square in CGS. So 5 meters squared is in SI units kada. Now I want you to convert this area into CGS. Cheppandi andariki. All of you, tell me. Yeah. Sir, time is scalar or vector? Time has no direction kada. So what is the time, sir? It is 6 p.m. upward direction. What is the time? 7 p.m. in the left side. No, it's a scalar quantity. Okay. So 5 meters kada. So 5 meters square ante 5 meter into 5 meters. Are meter into meter. Re. It should be meter into meter kada. So 5 into 10 to the power minus 2 or plus 2 re. So it should be 10 to the power 2 centimeter into 10 to the power 2 centimeter kada. So you can simply say 5 into 10 to the power 4 centimeter square. Ade. So 5 meter square is equals to 5 into 10 to the power 4 centimeter square. This is the conversion rate from SI to CGS. Cheppandi, convert 30 meter per second in CGS units. So what is CGS units? Right? So it is speed kada. So 30 meter upon second. So this is my SI units. E SI unit ki nenu CGS lo convert cheyale. So how would I do it? Right? I'll write 30 as it is. And I'll just change 1 meter ante how much centimeters? 100 centimeter kada. So it is 100 centimeter divided by second. Endukante time ki SI unit kuda second, CGS unit kuda second kada. So you can simply say this is equals to 3000 centimeter per second. Ade na CGS unit. Next, Sarji, convert 54 km per hour in meter per second. 54 km per hour in meter per second. Ela convert cheyala. So you can simply say this is 54 km per hour kada. Cheppandi. In 1 kilometer, how much meters are there? And in 1 hour, how much seconds are there? So you don't have to change this number, okay? Don't change 54. 54, you have to write it as it is. Now, instead of this kilometer, cheppandi. 1000 meters kada. Great, sir. And what about hours? Re? How many hours? How many seconds in 1 hour? Re? How many seconds? How many seconds? Good. 3600 seconds. So simplify cheste, these two zeros gets cancelled. So this is 54 into 2 5s are 10. 18 2s are 36 kada. So 5 by 18 meter per second. Students, ippadi nunchi gurtupettukondi, whenever you are converting kilometer per hour, I'm telling you one important thing, 1 kilometer per hour is equals to 5 by 18 meter per second. So to convert kilometer per hour into meter per second, you multiply it only with 5 upon 18. Similarly, cheppandi, what should I write here? 20 meter per second into kilometer per hour kada. So what should I write? What should I write? Tell me. So it is only 20 meters per second. Ante 20 meter upon second. Meter nunchi kilometer lo convert cheyalante em cheyali. So you can simply say 20 is 20 as it is. 1 meter is 10 to the power minus 3 kilometer kada. Divided by 1 second is how much? 1 upon 3600 seconds kada. Hours, it should be hours. Okay sir, ardhamaindi. Now I have to simplify. So 20 into reverse, andariki reverse. So it is going to be 3600 divided by 1000 kada. Again rendu zeros gets cancelled. 18 2s are 36, 2 5s are 10. So that means you have to multiply this by 18 by 5. 5 1s are 5, 5 4s are 20, ante 72 kilometer per hour. So the speed that you have in your bikes or cars, what is the unit for that? Meter per second or kilometer per hour? The unit of speed in your speedometers. Meter per second or kilometer per hour? So the speedometer that you have only has meter per second. Sorry, kilometer per hour, okay? So na daggara kilometer per hour unte I have to convert this into meter per second. Ela convert chestaru ante you simply multiply it by 5 by 18. Reverse unte if I have meter per second and nenu kilometer per hour lo convert cheyalante you simply multiply it with 18 by 5 kada ante. చెప్పండి అందరికి. What should I write? 27 people are there and only 20 likes are there. What? 20 also. 20 likes are there. 18 by 5. Ade. Good. Cheppandi. So I have to convert kilometer per hour into meter per second kada. Kilometer per hour to meter per second ante multiply by 5 by 18. So 90 kilometer per hour is equals to 90 into 5 by 18. So 18 ones are 18. So it is equals to 25 meter per second. Good. Next. Let's talk more about derived physical quantities. Cheppandi. SI unit of force, SI unit of acceleration, SI unit of speed, SI unit of energy, SI unit of power. So students, ఈ యూనిట్స్ ని డిరైవ్ చేయడానికి యూ మస్ట్ హ్యావ్ ఐడియా అబౌట్ ద ఫార్ములా. ఏదైనా ఫార్ములా ఉంటే ఇట్ షుడ్ జస్ట్ బి రిలేటెడ్ టు ఫోర్స్, యాక్సిలరేషన్, స్పీడ్, ఎనర్జీ అండ్ పవర్. ఓకే సర్జీ, ఐ విల్ ట్రై టు ఫైండ్ ద ఫార్ములాస్ ఫస్ట్. సో ఐ విల్ ఫస్ట్ ట్రై టు ఫైండ్ యాక్సిలరేషన్, ఎందుకంటే యాక్సిలరేషన్ ఈస్ డైరెక్ట్లీ యూస్ఫుల్ ఫర్ ఫైండింగ్ ఫోర్స్ కదా. Good. So let's talk about acceleration. Acceleration ki formula. The formula of acceleration. What is it? It is delta V upon delta T. Good. Now, what is the formula for speed? What is the formula for speed? It is distance upon time kada. So distance upon time is speed and delta T unit is T only kada. So you can simply say L upon T square. Or you can simply say meter upon second square kada. So you can simply say meter per second square is the SI unit of acceleration. Okay sir, ardhamaindi. Ippudu naku force ki SI unit kavali. So what should I do? I can simply say force is equals to mass into acceleration. Okay sir, ardhamaindi. Ippudu what? Mass ki SI unit cheppandi. kg kada. Into acceleration ki SI unit, we just found it now, meter per second squared. So ekkad nunchi you got the SI unit for force as kg meter per second square. Student, this quantity itself is known as Newton, or you can also say Newton. Can you remember this? When you're writing the full form, the n should be small letter, and when you're writing only n, the n should be capital letter. For example, I'm telling you force of 10 Newton. Good. Right? 10 Newton. Okay, sir. It is valid. Ekkada, if I'm telling you force of 10 Newton, ఇది కూడా valid, sir. Good. If I say you, let's say force of 10 Newton, wrong, not valid. Similarly, force of 10 Newton, you don't write it, okay? Arey, why re? Endukante scientists got crazy, re. They just invented, they just said, so we have to do it. Ade. So this is wrong and this is right. So now onwards, remember, ఎప్పుడైనా when I'm telling you 1 Newton అంటే 1 kg meter per second squared. అంతే కదా. So next we have to talk about force అయింది, acceleration అయింది, speed కూడా it is completed, right? Meter per second. Let's talk about energy, re. Let's talk about energy. What is the SI unit for energy? చెప్పండి అందరికి చెప్పండి. So to find the SI unit of energy, I need any formula for energy kada. So what is the formula for energy, re? What formula do I remember? What formula do I remember for energy? What formula do I remember? Kinetic energy. Oh, great. Arey, kinetic energy is half mv square kada. Okay, sir. What about this half? Does this half has any unit? No. ఇది యూనిట్లెస్ క్వాంటిటీ. ఇగ్నోర్ ఇట్. పుష్. ఎప్పుడు చెప్పండి మాస్కి ఎస్ఐ యూనిట్ ఏంటి? కేజీ. గుడ్ సార్. స్పీడ్ స్క్వేర్ కదా. సో స్పీడ్ కి యూనిట్ వాట్ ఈస్ ద స్పీడ్ ఆఫ్ వాట్ ఈస్ ద యూనిట్ ఆఫ్ స్పీడ్? మీటర్ పర్ సెకండ్. స్క్వేర్ చేయండి అని చెప్పండి. సో ద ఎనర్జీ యూనిట్ ఈజ్ కేజీ మీటర్ స్క్వేర్ పర్ సెకండ్ స్క్వేర్డ్. సో దిస్ ఈస్ ద ఎస్ఐ యూనిట్ ఫర్ ఎనర్జీ. కానీ వి ఆల్సో హ్యావ్ one more SI unit that is separately given to energy kada. So what is that? That is joule. Ardham ostindi kada. So you can say 1 joule is equals to 1 kg meter squared per second squared. Okay sir, I got it. Kani I remember something similar, re. What I remember something similar, I just did it previously kada. Chudu. Force is kg meter per second squared. Force is kg meter per second squared. It is kg meter square per second squared. So I can say 1 Newton is equals to 1 kg meter per second squared. And 1 joule is equals to 1 kg meter squared per second squared. Ekkad nunchi can I say, sir, 1 joule is equals to 1 Newton kg. Sorry, not kg, it's meter kada. So an extra meter has been added. చూడండి, kg same, second square same. The only change that I see here is this power 1 and power 2. అంటే 1 extra meter has been multiplied. So what should you write? చెప్పండి. You can simply say 1 Newton second. అంతే. So this is the SI unit for energy. అర్థమైంది? Good. So students, I want all of you to remember this, okay? 1 Newton is equals to 1 kg meter per second squared. This is equation number 1 and one of the most important equations. The second one is 1 joule, right? 1 joule. Ippude chusina kada. What is 1 joule, right? 1 joule is 1 kg meter square per second square. Ante. If you remember these two, your entire units and dimension is simplified by 50%. Ante. You only remember these two units. First about force, second about energy. Endukante even if you have hundreds of physical quantities, force is there, energy is there, momentum is there, torque is there, angular velocity, angular acceleration, impulse is there. Deentlo you can say all of them has the application of force somewhere, somehow. So remember, gurtupetkondi andariki the unit of force is Newton and 1 Newton is 1 kg meter per second squared. అర్థమైంది కదా? చలో. So I think we can shift to the next one. So students, I have to express the other quantities also, right? So for example 1 hertz is there, for example 1 ohm is there, 1 coulomb and 1 pascal. Pascal for what? Pascal is SI unit of pressure. Observe cheskondi. Hertz is SI unit of frequency. Ohm is SI unit of resistance. And coulomb is SI unit of charge kada. Cheppandi. What should I write? What should I write? What should I write? These are all the derived quantity. Remember andariki, frequency is a derived quantity. Resistance is a derived quantity. Charge is also a derived quantity. Ekkada pressure kuda, it is a derived quantity. So ee mottam find cheyadaniki, first of all tell me the formulas re. What were the formulas? Hint lo first one is frequency kada. So what is the formula for frequency, sir? Sir, formula for frequency, sir. Sir, what is the formula for frequency, re? Frequency. What should I write? What should I write? Frequency is what? I remember, sir, wavelength of light is equals to something, or speed of light is equals to, what is it? What is it? What is it? Speed of light is equals to wavelength of light into frequency of light. Something like this, kada? Okay, sir, this is the only formula I'm remembering. Good. So here, can I say frequency is equals to speed of light upon wavelength? Good. Okay, sir, cheppandi. Speed ke unit enti? SI unit of speed is meter per second kada, divided by SI unit of wavelength. Length ki unit enti? Meters. Okay, got it. So, and this gets cancelled, and I'll simply get frequency ki SI unit is 1 upon seconds. And 1 upon second, 1 upon second is known as 1 hertz. Ekkad nunchi gurtu pettukondi, it is a very important result andariki. Next chuddam, we are talking about ohm re. 1 ohm resistance ki formula enti ra? What is the formula for resistance? What is the formula for resistance? And how should I find the resistance, re? Sir, I don't know the formula for resistance, sir. Kani in class 10th lo, there was a formula. What was the formula, sir ji? There was a formula for heat generated in the resistance. What was the formula for heat generated in the resistance? Sir, it was something like H is equals to I square RT kada? Wow, I square RT. Good. So I ante enti, sir? Current. Current is a derived fundamental unit kada. Good. So you can say heat is energy. Heat energy ra. We just calculated the unit for energy. Cheppandi. What did we write about energy ra? 1 joule is equals to 1 kg meter square per second square. So energy ki SI unit ante kg meter square per second square. Remember kg meter square per second square. Kg meter square per second square. Kg meter square per second square kada. Right. So kg meter square per second square is equals to I square. I square is what? I is current. Current is a fundamental quantity. So I is ampere square kada. Good. Now I'm talking about resistance. I don't know the value of resistance, but I know the unit of time. What is it? It is second kada. Good. So ekkad nunchi you can simply say resistance is equals to kg meter square per second squared. These are in multiplication. Ekkada pampendi. These will go in division. So this is my second and this is my ampere square. So you can simply say resistance is equals to kg meter square per second cube ampere square ante. And this quantity I call it as 1 ohm. Oh wow, nice. Next, let's talk about coulomb re. Coulomb ante enti ra? Coulomb is charge kada? Okay, charge. Charge ki also there was a formula. What was the formula re? In class 10 there was a formula for charge. Hey babu, what was the formula re? Q is equals to I into T kada? Ide the formula. Kani I is a fundamental unit, time is also a fundamental unit. It is a very simple thing for me. Substitute cheskondi. I is ampere and T is second. Ante. So 1 coulomb is equals to, whatever the spelling rate. 1 coulomb is equals to 1 ampere second kada. So 1 coulomb is 1 ampere second. Ante. And the last one, andariki, cheppandi. What was the last one? Pascal. Oh, Pascal. Pascal is a unit of pressure. Pascal is a unit of pressure. So 1 Pascal is equals to, what should I write for pressure? Formula. What is the formula? What is the formula? What is the formula for pressure? There was some formula for pressure in class 10th. What was the formula in class 10th? There was some formula in class 10th for pressure. Force upon area, sir. The pressure is force upon area, kada. Good. So force ki unit, what is the unit for force, sir? Force is kg meter square per second squared divided by area. Area ki aisa unit entira. Area ki aisa unit meter square kada. Good. So it is meter square. So meter square gets cancelled. And you can simply say, cheppandi. It's not meter square. Force ki SI unit is not meter square. Kg meter per second square kada divided by meter squared. Ante. Substitute chesi, this m and this m will cancel, and you are left with kg upon meter into second squared. Ante. Chalo, let's shift for the next one, right? Dimensions, ra. What is dimension? What is dimension, right? What is dimension? Dimension ante, it is only the power of existing fundamental physical quantities in any given quantity. Observe, all of you. Dimension is only a number. It is only the power of existing fundamental physical quantities. For example, if I am talking about speed, you keep this in your mind. Whenever we are talking about dimensional formula, we use this bracket. What is this bracket? This bracket is a square bracket. And what can I say? It is only used to find the dimension. Dimension related problem ante, I'll just use this square bracket. Good. So, speed ki SI unit chusina kada. So, what is the SI unit for speed? Sir, it is meter per second. Ante. Kani, you have to write the quantity or unit of meter. What is the unit? What quantity has the unit of meter? Length. And what quantity has the unit second? Time kada. So, you can simply say dimensional formula for speed is length upon time. Ardhamainda? Kani, you can simply say 1 upon t is equals to t to the power minus 1 kada. So you can also write L upon t is equals to L into t to the power minus 1. Good. So you can say dimensional formula for velocity is Lt to the power minus 1. Got it. So students, ekkad nunchi you observe one thing. Whenever you are talking about dimension are only the numbers. Idi speed ki dimension kaadu. This is the dimensional formula for the speed. When you talk about the dimension, so the dimension of speed, or you can say, did I write? See, dimension of velocity is 1 in length. Choose kondi 1 in length kada, and minus 1 in time. Similarly, if I am talking about dimension of acceleration, cheppandi, what is the dimension of acceleration? What is the dimension of acceleration? So for that, write the formula, sir, or write the SI unit. What is the SI unit of acceleration? Meter per second square. Ante. Sir, meter is a unit of length. And second is a unit of time. So L upon t square. Kani, I don't write division into it. I can't write division. So I'll simplify and I'll write Lt to the power minus 2. Good, sir. So the dimensional formula for acceleration is this. So ide ante acceleration ki dimensional formula. But it is not the dimensions kada. Good. So when I talk about the dimension of acceleration, it is 1 in length. Power ni chuskondi. What is the power of length? 1 kada. So the dimension of acceleration is 1 in length and -2 in time. Ante. So this is the dimension of acceleration. Chalo. Good. Good, sir. Good. Ardhamaindi. So now we have to find the dimensions and dimensional formula for the following. How many quantities? 10 are there. I'll only do the 5. Alright, we did it. Anyhow, we talked about force, area, volume, velocity, acceleration. I'll start from 6, okay? So I'll only write these 6 values and akkad nunchi you can find the. So let's talk about power first. Okay, sir. Power ki formula enti? Do I remember some formula for power? Power ki enti formula edaina unnadi? You remember some formula there was there, it was in class 10th, there was some power formula. What is the formula for power? Work upon time kada, the P is equals to W by T. Good. W ante enti ra? What is W now? W, sir, we have seen somewhere. F into S. Good. So W is F into S divided by time T kada. S is what? Distance. T is what? Time. Distance by time. Speed. Good. So can I say force into speed? Good. Sir, so that is the formula for power. Can I have to also write the SI units of both of them? I have told you, students, you remember everywhere in all 6, 7, 8, 9, 10, force is useful. Kabatti, you have to remember the SI unit and also the dimensional for force. Dimensional formula for force. Cheppandi. Force ki SI unit enti ante, sir, it is kg meter per second squared. Multiplied by speed ki SI unit enti ante, it is simply meter per second kada. Good. So multiply chesi, I come out as kg meter square per second cube. Ante kada. Now it's not done yet. I have to write the quantities for which the SI unit are this. So kg ante it is SI unit of mass and power 1, so it is power 1 also. Meter square ante length ki SI unit, so I'll write length to the power 2. And ekkada S cube is in division, so I'll simply say second is the unit of time and it is power -3. Ante. So this is the dimensional formula for power or dimensions of power. Ardhamaindi? Good. Chalo. Let's talk about momentum, re. What is momentum? Re? Momentum. Sir, momentum ki edaina formula gurtunda? What should I write about momentum, re? Momentum is P kada. P is equals to mv. Good. So P is equals to m into v. What is the unit of mass? Mass ki unit ante kg. And what is the unit of speed, re? Meter per second kada. Good. So kg meter per second is the unit of momentum. Kani I want the dimensions of it. So cheppandi, the dimension of P is kg is for mass, meter is for length and second is for time. M L T to the power -1. So it is for the momentum of formula of momentum. If we will talk about impulse. What is impulse? You don't know, I'll tell you. Don't worry. Chalo. So you can simply say impulse could be written with the letter J. And you can simply say impulse is equals to F into time. F into T. Ante. Cheppandi. F ki standard unit enti ante kg meter per second squared. Multiplied by time ki unit ante second. So you can simply say cheppandi. What is impulse? Impulse ante kg meter per second. Ante kada. So you talk about the dimensions of impulse. So it comes out to be kg ante mass, meter ante length, second ante time. Ade. చలో నెక్స్ట్ ఏంటి అంటే ఎనర్జీ కదా. ఎనర్జీ వి జస్ట్ రైట్ ఇట్ నౌ ఓన్లీ కదా. లెట్స్ టాక్ అబౌట్ టార్క్ నౌ. సో యూ డోంట్ నో ద ఫార్ములా ఆఫ్ టార్క్. ఐ విల్ గివ్ యూ ద ఫార్ములా ఆఫ్ టార్క్. చెప్పండి. సో యూ కెన్ సింప్లీ సే టార్క్ ఈస్ బై దిస్ లెటర్ tau. Torque is simply equals to F into L. Ante. So if it's for perpendicular, you do have different formulas. Kani its simple formula is F into L. So cheppandi sir ji, F ki SI unit ante kg meter per second squared into length is meter kada. So it is equals to kg meter square per second squared. So this is the unit of torque. Okay sir. How would I convert into the dimension of it? So dimension of torque is equals to cheppandi mass to the power 1, meter is for length to the power 2, second square is t to the power minus 2, ml to t minus 2, ml to t minus 2. Re. I've seen somewhere. This is classic. I've seen somewhere. Re. Where did I see this? Where did I see this? Kg meter square per second square kada. Kg meter square per second square. Joule. Cheppandi. Kg meter square per second square. Kg meter square per second square. Kg meter square per second square. Where are you? Here it is. Yeah, here it is. Cheppandi. Kg meter square per second square is for torque. Also for joule it is kg meter square per second square kada. So the dimension of torque and the dimension of energy are the same. So you write this. It has been asked, okay, which of the following quantities do have same dimensions? It could be asked this way also. Entamandi unnaru? I mean, if you're there. Chalo, good. Next ki veldam sir ji. Let's talk about the next quantities. I gave too much space re. Yeah. డైమెన్షన్లెస్ క్వాంటిటీ గురించి మాట్లాడతాం. ఏంటి రే డైమెన్షన్లెస్ క్వాంటిటీ అంటే ద క్వాంటిటీస్ దట్ డు నాట్ హ్యావ్ డైమెన్షన్స్. ఓకే సార్, బట్ వాట్ ఆర్ దే? కెన్ ఐ సే నంబర్స్ రే? నంబర్ అంటే 2 కి డైమెన్షన్ ఉంటుంది కదా. నో, ఇట్స్ నాట్ దే. 1 2 3 4 5 pi is also not having any dimensions. Similarly, sir ji, E is also not having any dimensions. Sir, similarly, what can I say? Root 2, root 3, root 4, everything. These are all the dimensionless quantities kada. So, whenever you're talking about a single number, observe cheskondi. Hairline difference untundi. Just a hairline difference where the numbers do have dimensions and they do not have dimensions. You must be very good with where the numbers are having dimensions and where they are not having the dimensions. So sir, numbers whenever they are alone. So for example, if I tell you the dimension the dimension of pi is 0. Good sir, I got it. So that means, let's compare. Let's write an area formula. Area of a circle is pi r square kada. Area ki dimension enti? Area ki dimension ante length square is equals to dimension of pi multiplied by radius is also length kada. So radius square ante length square. So length square is there. That means the dimension of pi is 1. 1 ante length ki power 0 kada. Good. So you can simply say pi is a dimensionless quantity. Similarly, 1, 2, 3, 4, these numbers kuda, you can tell them they are the dimensionless quantities. Kani. There is a twist. I'll tell you later on. Let's move to the next part of the discussion. What is unitless quantity? What is unitless quantity? What is a unitless quantity? Sir, what is a unitless quantity? Unitless quantity ante the quantities that do not have a unit. For example, let's say na దగ్గర 2 is there. It does not have any unit. Let's count the numbers. There is class 5 students. I am teaching very cheppora 1 2 3 4 5 6 is telling 1 2 3 4 5 6 no units at all. etc. So Sarji, we have seen about the dimensionless quantities also here. Same, and also we have seen about the unitless quantities. Sir, quantities are same, but why we are differently naming them unitless and dimensionless? Endukante chudandi, here when you talk about, let's say na దగ్గర ఒక quantity ఉంటుంది. Do you remember like droppers are there kada? So droppers andariki, do you remember the formula for coefficient of restitution? What is the coefficient of restitution re? E kada? It is equals to velocity of separation divided by velocity of approach kada? చెప్పండి వెలాసిటీకి డైమెన్షన్ ఏంటి? మీటర్ పర్ సెకండ్. ఎక్కడ కూడా వెలాసిటీకి డైమెన్షన్ ఏంటి? మీటర్ పర్ సెకండ్. ఐ మీన్ ఫార్ములా SI యూనిట్స్ కదా. సో మీటర్ పర్ సెకండ్ గెట్స్ క్యాన్సిల్డ్. And thus, even if the formula is having dimensional quantities in it, the original value is without any dimension. So here you can say E is a dimensionless quantity. And unitless quantity ante you can simply say numbers 1, 2, 3, 4, 5, 6 are there. Observe cheskondi, a dimensionless quantity may have units. A dimensionless quantity may have units. Units are? Is it? But a unitless quantity cannot have dimension. I am leaving statement on you. Tell me, is this statement true or false? Chalo, let's move toward the next statement. Plane angle and solid angle have both units and dimensions. Units but no dimensions. Dimensions but no units. And no units and no dimensions. And there, when you talk about it, Ray, what spam are you doing, Ray? Chalo, let's see. Plane angle and solid angles have. Sir, plane angle గురించి మాట్లాడితే I have seen something like degree kada. 2 degree, 3 degree, 4 degree is there, 90 degree angle is there. So Sarji, plane angle has units. ఎందుకంటే I can write it in n into u form. n అంటే 90 and u అంటే degree కదా. Good. So sir, I can also write it in another form. So pi by 2 కూడా రాయొచ్చు కదా. So pi by 2 radians would be there. Radians రే. చెప్పండి. So 90 degrees there, pi by 2 radians is there. So అంటే it has some value. It has also got some units. కానీ dimensions గురించి మాట్లాడితే it had no dimension కదా. So it has a unit but no dimension. ఎక్కడ కూడా solid angle గురించి చెప్తే solid angle is angle of a cone, something like this. Kada? So it's there in 3 dimensions, something like this. See, like this ray. Like this ray. So it has a unit. So until when you talk about solid angle, the unit is steradians. So for example, 4 pi steradian is there. Ante unit untundi, but dimension is not there. So that means both of them have units but no dimensions. This was asked in NEET 2022. Next ki veldam ra. If E and G are energy and gravitational constant, then E by G has the dimension of what? Cheppandi. Ray, what Ray? Why are you doing Ray? Cheppandi andariki. Okay, so if E and G are energy and gravitational constants, energy gurinchi we talked just now kada. We talked about energy ray. Energy was having kg meter squared per second square kada. So I have the unit of energy, కానీ I don't have the units of G. So ఎలా ఫైండ్ చేయాలంటే you have to remember the formula. ఏం ఫార్ములా ఉంటుందిరా నా దగ్గర? Can I say force is equals to G into m1 m2 by r squared? What sir? What are you doing sir? All these are class 10th formula sir. Why you are not teaching something different sir? చెప్పరా force ki SI unit ఏంటి? kg meter per second square kada. So that is equals to G into mass m1 ante kg. Similarly mass m2 ante kg divided by radius square ante meter square kada. పంపేయండి in this side. Tell me. చెప్పు. So it is gonna be kg meter by second square kada, into this meter square denominator, you send it in numerator. Kg square numerator, you send it in denominator. And that is equals to g kada. So this kg gets cancelled. Meters into meter square becomes meter cube divided by second square into kg. So ide g ki SI unit. Kani I want the dimension of it. So ela find cheyala dimension. So you can simply say dimensional formula for g is equals to cheppandi. Meter cube ante length cube kada. Similarly, kg is in denominator. Kg is in denominator ante kg to the power minus 1 kada. Minus 1. Good. And second square is also in the denominator ante time ki power minus 2. Ade. So this is the dimensional of g. And this is the dimension of energy. Cheppandira. Energy ki dimensional formula enti? Sir ji, kg ante mass, meter square ante length square, and second square ante t to the power minus 2. What is it asking re? E upon g kada. Substitute E by G. What gets cancelled? So sir, this is m by m to the power minus 1. Sir, this minus 1 will go in numerator and becomes m to the power 2. So the dimensional formula for E upon G can be given as m to the power 2. Ekkada chudandi, it is L square and it is L cube kada. So it goes up and it becomes L to the power minus 1 and it is t to the power minus 2. Ekkada kuda. So ante. So this is the dimensional formula for E by G. Next, let's talk about dimension of various coefficients. నా దగ్గర రకరకాలుగా కోఎఫిషియెంట్స్ ఉంటుంది. The first one is coefficient of viscosity, friction, restitution, Planck's constant, gravitational constant. It is recommended that you know the formula for each and every one of them. కానీ even if you don't know all of these, students, remember, even if you don't remember the formulas for all of them, I want you to at least remember the formula for force. What is the formula for force ray? It is m L t to the power minus 2. Ade. You remember this formula. Endukante if you remember force only, you can tell about torque, you can tell about energy, you can tell about impulse, you can tell about magnetic force, magnetic field, flux, electric force, electric field. Anta, I'm telling you, 80% of the physics it is only revolving around your force. Ante. So if you remember this force formula, you remember everything. If you don't remember it, you're gone mad, gone. Next, let's talk about the coefficient of viscosity. Arey sir, you're talking about something new, re? Viscosity ante, have I seen this word before? Viscosity. What is viscosity, re? I don't know, I'll tell you. You just see this. F is equals to 6 pi eta RV. This eta ante coefficient of viscosity. Good sir, good, I understood. Cheppandi. So ekkada nunchi, what can I write about eta re? Eta can simply be written as force upon 6 pi RV. R ante enti sir? Radius, distance, length. Good. V ante enti sir? Speed. R ante radius and V is for speed. And pi, you know it, right? It is a dimensionless quantity. Good. So cheppandi ekkada nunchi force ki SI unit ante kg meter per second square. Arey, where did I write it? I written here. See, applicable kada. Directly use అయింది. So you divided by 6 pi is a dimensional quantity. Remove it. చెప్పండి. R కి dimension అంటే మీటర్, స్పీడ్ కి dimension అంటే మీటర్ per second కదా. Good. So now you try to simplify it. So tell me, చెప్పండి, kg meter per second squared, I written it like this, divided by, it is meter square per second kada. Reverse cheskondi, you can simply get as second by meter squared. So this meter gets cancelled. You're left with, and second also gets cancelled kada. So you're left with kg upon meters second. Ante. So you can simply say it is equals to kg ante mass kada, meter ante length, and second ante time. M L minus 1 T minus 1 is the dimension for coefficient of viscosity. Good, sir. Ardhamaindi, sir. Let's go towards the next. Coefficient of friction. Droppers, cheppandira. Where do you use coefficient of friction? Sir, we use it in friction force and we write it like this. Array, I'll take on the next page itself. Array. Okay, so let's take coefficient of friction. So, sir, coefficient of friction is used in this formula. F is equals to mu into N. Mu ante coefficient of friction. What is N, sir? What is N? N is the normal reaction, kada. Normal reaction, what is normal reaction, re? Normal reaction is also a force, re. Normal reaction is also a force. So, ekkad nunchi you can say force is equals to mu into force, kada. So, mu into N, what can you say about mu, re? Mu is force upon normal reaction, kada. So, this is also kg meter per second squared. This is also kg meter per second square. Gone, re? It is dimensionless quantity. Mu is a dimensionless quantity. Good, re. Good, you understood, re. You understood, re. Let's talk about coefficient of restitution. Eppude cheppina kada. You see, coefficient of restitution is the coefficient. Where is it? Here it is. Coefficient of restitution. Velocity of separation by velocity of approach. Ante meter per second by meter per second cancel aitadi. It is a dimensionless quantity kada. Where is the space? Where is the space? Where is the space? Chalo. So let's talk about coefficient of restitution. So, sir, it is equals to E and it is written as velocity of separation divided by velocity of approach. Sir, where is it useful, sir? It is useful when collision is happening. I'm slapping everybody. So, you can say coefficient of restitution is there. So, it is meter per second. Ekkada kuda meter per second. Here also. Cancel out, sir. 1 aitadi ante it is a dimensionless quantity. So, students, observe cheskondi, some coefficients do have dimensions and some coefficients do not have dimensions. Ardhamaindi kada? Andariki. Chalo. Next gurinchi maatladam re. What is next? Planck's constant and then gravitational. Gravitational constant aindi kada? We are done about gravitational constant. I'm only talking about Planck's constant now. I don't have time. The pages are less, re. Let's talk about ఏం చెప్పాలరా ప్లాంక్స్ కాన్స్టెంట్ గురించి గుర్తుందా ఏమి ఫార్ములా ఏదైనా వాట్ ఎవర్ ఫార్ములా ఇస్ దేర్ అబౌట్ ప్లాంక్స్ కాన్స్టెంట్ సార్ ఐ నో ఫార్ములా సార్ ఇట్ టాక్స్ అబౌట్ ఎనర్జీ సార్ ఎనర్జీ అంటే ప్లాంక్స్ కాన్స్టెంట్ సేస్ సింప్లీ E is equals to H into F. F అంటే ఏంటి అంటే ఫ్రీక్వెన్సీ కదా. What is frequency, re? We discussed just now, re. Focus on your brains, re. Frequency is 1 upon second, kada? 1 upon time. Good, sir. So I can simply say energy upon frequency is H. Energy unit, sir. What is energy? I discussed just now. Kg meter square per second square, kada? So it is kg meter square per second square. For those who don't remember this, go back in the lecture. See, I have written this formula and come back again. Divided by frequency ante 1 upon second ra. It goes up. Cheppandi. So what's happening now is kg meter square by second square into second by 1 SS gets cancelled. What is remaining, re? Kg meter square upon second kada. Cheppandi. So dimensional formula for Planck's constant ante kg is mass to the power 1, meter square ante length to the power 2, per second ante t to the power minus 1. I don't know, like it is too much cold, right? Should I turn AC, re? How to turn this off? It's not getting off. Chalo, thank God, it is off now. Yeah, cheppandira. Now let's move towards the next slide. Okay, let's talk about principle of homogeneity. Sir, enti sir principle of homogeneity? Ela cheppale? What would you say, sir? Sir, it says in equation the dimensions of both sides should be the same. Okay, ardhamaindi. That means if I say I have 3 kg of mass, I add 2 kg into it, it becomes 5 kg. Okay, sir, if A is equals to B plus C, it is the formula or the equation. ఈ ఈక్వేషన్ లో A కి డైమెన్షన్ కూడా B కి డైమెన్షన్ కూడా C కి డైమెన్షన్ కూడా అంతా సేమ్ ఉండాలి. గుడ్ సర్ జీ. యూ కెన్ యాడ్ ఆర్ సబ్ట్రాక్ట్ ద క్వాంటిటీస్ హ్యావింగ్ సేమ్ డైమెన్షన్స్ కదా. 2 kg ఆఫ్ రైస్ ప్లస్ 7 kg ఆఫ్ రైస్ అంటే 9 kg ఆఫ్ రైస్ ఉంటుంది. కానీ అదే 2 kg ఆఫ్ రైస్ లో 7 లీటర్ ఆఫ్ ఆయిల్ యాడ్ చేస్తే ఏమవుతుందిరా? ఏమైతుంది? వాట్ హ్యాపన్స్ ఇస్, sir, I will getting good solution, I will go and cook and eat it, sir. Ade. So you cannot say like that, right? So whenever you are doing the addition or subtraction, the only condition is that the dimension should be the same, the unit should be the same. Ante. So this is the principle of homogeneity kada. Students, you can also say this to be the dimensional analysis. Dimensional analysis kuda you can tell it for the principle of homogeneity. It is very useful for your examination. Cheppandi rules okkasari we will just revise it once again. Okay, you remember whenever you are adding or subtracting, or let's say A is equals to B minus C, even in this scenario your A dimension, your B dimension or your C dimension should be the same. Endukante you can only add the terms having the same units or the same dimensions. Array, it's not same ray, it is the same ray. So you can say you can add only and only when there is same dimension quantities. Ade, Sarji, I'll use the application now and I will try to jump to the questions directly. Okay, cheppandira. Acceleration is given by bt plus ct square. The dimension of B and C are what? So sir, ippude nenu chusanu kada, if I am telling A is equals to B plus C ray, if I am telling A is equals to B plus C ray, then the dimension of A should be equals to the dimension of B, and that should also equals to the dimension of C. Evaraina, any one of you tells me, sir, no, the dimension of A is equals to dimension of B plus dimension of C, I will kill you. Ardhamaindi? It is not right. It's not the equation. You remember this. It is not correct. The correct one is this. So that means acceleration ki dimension, BT ki dimension and CT square, all three should be the same kada. Good. So Sarji, I can simply say the dimension of acceleration should be equals to the dimension of BT. And that should also be equals to the dimension of CT square. Good, sir. I got it. Cheppandira. What is the dimension of acceleration, right? What is the dimension of acceleration? Andariki. The dimension of acceleration, sir, it is meter per second square. Kani, sir, it is length upon t to the power minus 1. Good. That is equals to the dimension of B into t. So here onwards, aim ravalante, you do one thing. It is multiplication. Send here. It comes in division. So LT to the power minus 2 by T ante, it is going to be LT to the power minus 3. First answer ochindi. Let's go for the second one, sir. In the second one, it is CT square. Okay, Sarji, again I am writing the dimension of acceleration is equals to C into T square. Ekkad nunchi the acceleration ki dimensions ante LT to the power minus 2 is equals to C into T to the power 2, Sarji. It is in multiplication. Send here. It comes in division. So I will be left with dimension of C is equals to LT to the power minus 2 by T to the power minus 2 ante LT to the power minus 4. Ochindi kada? So here onwards, you can simply say the dimension of B is equals to LT to the power minus 3. Ikkada the dimension of C ray, C. So the dimension of C is equals to LT to the power minus 4. Ante kada? Good. All of you, how is the energy ray? Why are you so dull ray? Andariki, how are you? Re, cheppandira. Energy, how is the energy? How is the energy andariki? How is the Josh, ra? How is the Josh? Next. Next, the force on a particle is given by this. Dimension of A and B, I want to find it. Ela find cheyalara? Again, you apply the same formula. Okay, again the same formula. Cheppandi, andariki cheppandi. Force is equals to A upon T minus B upon T squared. What would you write here, sir? You will write the same thing. What same thing? Ante the dimension of force, dimension of A by T, dimension of B by T square, mottam should be same kada. Good. No energy, sir. Meeru also third works. What happened, Nandini? What happened? Why no energy, Nandini? Chalo. Let's go for this question. The dimension of force ante entira? I told you multiple times. Remember, daichesi remember the formula for force re. What is the dimension of force re? M-L-T minus 2 re. Good. Now I have this A upon T kada. Are T is there re? I missed one box. So this T is division. You send here in multiplication. So sir, M-L T to the power minus 2 into T is equals to the dimension of A. Ante the dimension of A is simply going to be M-L T to the power minus 1. Ekkad nunchi you do it by yourself for B upon T square. I'm directly writing the dimension of B is equals to M into L. Ade. See, I'm not writing as M into L, so the T term is missing kada ikkada. So you can simply say it is simply equal to M power 1, L to the power 1, T to the power 0. So this is the dimension formula for B. You can write whatever you want, okay? Ela kuda raichu. Next. If the force F, acceleration A and time T are chosen as the fundamental physical quantities, the dimension of energy is what? NEET 2021 lo this question has been asked. So sir ji, I will have to solve it. Kani sir, I am scared to do this, sir. So let's say, sir, I have the formula for force is M into L into T to the power minus 2. I have the value of acceleration A kada. So you can simply say, sir, the dimension formula for acceleration is LT to the power minus 2. You must remember this. You cannot derive and sit in the examination, sir. Acceleration is meter per second square. You cannot do all of that, you know. Time is very less. Hardly 1 minute of time is there for you. Okka nimisham what will you do, Ray? What will you do? You will write the formulas also, you will solve also, you will read also. It is total mess. You remember, we have studied so many questions, so by this time, meeku formulas gurtundalera. Are at least do something, Ray. Cheppandi. Time is there kada. So the dimension of time is only T itself. So these are my physical quantities. Okay, sir. I have to write the energy kada. Energy ki unit kavale. What is the formula for energy? Without formula, you cannot attempt this question. Okay. So what is the energy? What is the formula for energy? Cheppandi andariki. What is the formula for energy? Okay, so what is the formula for energy? 16 people are only watching. Okay, yeah, cheppandi. The formula for energy, sir, it is around kg meter square. So kg meter square per second square. So sir, I will try to take something common into it. So Sarji, this is the unit of energy, this is the unit for force. What is the unit of force? Kg meter per second square kada. Okay. What else, right? What else? Time is there kada. Time. What can you write about time, right? You divide it, right? You divide it. Tell me. So you will simply get the dimensional formula for E divided by dimensional formula for F is equals to kg cancelled. Second square cancel, meter square meter cancel ante only meter kada. So you can simply say dimensional of energy is equals to dimensional formula of force into length kada ante. Yeah, you can write it like this, right? Length itself, or you can, but you have to write in terms of A and T kada. You have to write in terms of A and T. So you don't have to write this L ekkada. So how can I do, re? How can I do? I can do one thing, re? I can square this T square and I can multiply A into T square. Multiply cheste this minus 2 gets cancelled and only left with this L. So ekkad nunchi I can simply say this is F into A into T square kada. Sorry. So it is A into T square. So this is my dimensional formula for energy. Ardham cheskondi. If you understand, well and good. Don't understand, revise it and see it again. Next ki veldam ra. Observe cheskondi trigonometric functions. All of the trigonometric functions, sine, cos, tan, cot. Radius for L. Raju, radius is length kada. How can you write mass m ra? Mass m is for kg, okay? M is for mass, not for meters. Meter is a length, so you have to write L. Cheppandi. So in this scenario, if at all I have F is equals to A times of sine of B, A ki dimension and B ki dimension I have to find it. So observe cheskondi, the first thing is that whatever you are keeping in sine, cos, tan has no dimension at all. So ekkada chuskondi sine lo B untundi kada. So e B should be dimensionless, re, simply dimensionless. So you can simply say the dimension of B is nothing at all. So M0, L0, T0. Ante kada. So if it is getting dimensionless, e sine kuda it completely gets dimensionless. So you are only left with dimension of F is equals to dimension of A. Endukante trigonometric functions are dimensionless. So now, Sarji, the dimension of A is nothing but the dimension of force. I told you to remember the dimension of force. It is mLt to the power minus 2 kada. Done. So ante sir, the dimension of B is this and the dimension of A is this. Ochina kada? Good. Now I have to find the dimension of K in sin kx. X is for length. Andariki X is for length. And I have to find good. Naina, very good. Chalo. So I have to find the dimension of K. Well, what should be the dimension of K? Re? The dimension of K should be such that K into X becomes dimensionless. Endukante whatever is there in sine must be dimensionless. Okay, Sarji, the dimension of X is length. To cancel out, the dimension of K should be L to the power minus 1 kada. So L into L to the power minus 1 becomes dimensionless. So ekkad nunchi you can simply say the dimension of K is L to the power minus 1. Good. Next. The velocity of a particle is given by V is equals to AT plus B upon T. Find the dimensions of A and B kada. Cheppandi andariki. What is the dimension of A and B? Okay, sir. Ippude chusina kada the dimension formula and the application of it. So you can say the dimension of V should be equals to the dimension of AT should be equals to the dimension of B upon T. Ardhamaindi kada? So cheppandi andariki, what is the dimension of V ra? Meter per second. Meter length second time LT minus 1 is equals to A into time T. T is time, okay? A lot of people do suit NEET and JEE because they, I have not written time here. So what they do is they say to NTA that, sir, you have not written T. So T is for time or T is for thickness. If it is thickness, sir, it will have the dimension L. If it is time, it has the dimension T. So you have not mentioned it, sir. So you cannot cut our marks. We will go to Supreme Court now. Arey, whatever re. Arey, observe re. Hey, T is for time re. Okay, T is for time, not for thickness. Time. Cheppandi. This T is for time. Send it there. So you can get the dimension of A is equals to LT to the power minus 2. Here also, the dimension of V should be equals to B upon T kada. So the dimension of V is what? Meter per second ray, LT to the power minus 1 ray. So it should be B upon time ray. This time is in division ray. Send it in multiplication ray. You are getting LT minus 1 into T ray. This TT gets cancelled ray and you are only left with the dimension of B is equals to cancel out, only left with length. So B is the dimension for distance. Next. Now students, Chudandi, I told you when I was explaining the dimensionless quantities, if you remember this or not, right? I mean, I don't know how many of you have left at that time. Kani, I told you. What did I tell you? I tell you that numbers have dimension or they don't have dimension. Sir, numbers are dimensionless. Kani dimensionless unte, how am I asking you to find 2, 3, 4 ki dimensions? Ra? Equation lo, epadaina numbers are there, they may have dimensions as well. Kani, when they are coming independently, the dimension of 2 is 0, dimensionless. The dimension of pi is 0, dimensionless. But when they are in the equation, the dimensions will not be 0. Ardhamaindi andariki? Okay, sir. So find cheddam. So I have given f is equals to 2a plus 3t minus 4v kada. Raskondi, this question is actually incomplete. Endukante I did not specify you. This A is for acceleration, this T is for time, and this V is for velocity. Kada A is for acceleration, T is for time re baba, and V is for speed re. Chuskondira. These are the information I should have given you. I have given you now itself. Don't worry. Cheddam andariki cheppandi. So the dimension of force should be equals to the dimension of 2 into A, equation number 1. The dimension of force should be equals to the dimension of 3 into T, equation number 2. Here also the dimension of force should be equals to the dimension of 4 into V kada. So 4 into V. Okay sir, ardhamaindi. Just tell me what to do now. So to do something, write the dimension of force ray, mlt to the power minus 2 ray. It should be equals to 2 into dimension of A ray, acceleration ray. Acceleration is meter per second square ray, lt to the power minus 2 ray. So you can simply say the dimension of this 2 is coming out to be lt minus 2 gone. So this is equals to m. And this is why the JEE advanced people, whenever they make any question paper, oka question lo mamulga 4-5 concepts, they mix it and they ask it. And whenever they are giving the numbers, they also specify the dimensions of them also. Okay. Okay, good. Eka cheppandi. The dimension of force ante mlt to the power minus 2 is equals to 3 into the dimension of time ante t kada. So this T, you send it over here ray, you get the dimension of 3 ray. What you get it ray? I am directly writing it as mlt to the power minus 3. Ekkada vachesi you can say that the dimension of force is again mlt to the power minus 2 is equals to 4 into meter per second kada, lt minus 1. Cheppandi. So the dimension of 4 over here, tell me, it is equals to mt to the power minus 1. So I got the dimension, sir ji, I got the dimension for 2 also, I got the dimension for 3 also, and I got the dimension for 4 also. And then the numbers do not have dimension ray, then how they are coming ray? Again I will tell you, whenever the numbers are coming alone, then you kill them. But they are not coming alone, right? They are coming with some other numbers. You can't kill them. Ardhamaindi? Good. Mysterious. Very good. Chalo. Next. This E is for energy kada, and this X is for length re. This E is for energy, this X is for length, and this T is for time. ఇప్పుడు చెప్పండి, how would I write? So energy ke dimension, sir. What is the dimension of energy, sir? We did it 3-4 times, sir, but still we don't know, sir, because we are chatting and spamming the chat section, sir. Cheppandi, the dimension of energy is mL2 t to the power -2 kada. Okay, it is equals to A into the dimension of X. X is length. So I have written length here plus, what should I do now? It's a twist, Ray. It's a twist, Ray. Endukante it is BT by CT, C up minus T squared. So BT divided by C minus T squared. It is a term in the addition or subtraction. Kani, I can simply not tell about the dimension of BT by C minus T squared. Endukante this is the dimension for energy. This should also be the dimension for energy itself, because they are in addition kada. And this all mottam should be the dimension of energy itself. Ekkadi nunchi kuda. Okay, sir. Kani, you see here this C minus T square kada. C minus T square, C minus T square are getting subtracted. C minus T square is getting subtracted. So, sir, we can only subtract when the dimensions are same. 1 kg plus 1 kg is 2 kg. So that means the dimension of C should be equals to the dimension of T square. So the dimension of C, I got it as T square. Ante, this is my first answer for the question. C kada, C ochindi, C. T squared. Okay, sir. Now this entire term, endukante the expression is E is equals to AX plus BT divided by C minus T square kada. It is for energy. Good. And ardhamaindi, it is also for energy. Endukante the equation is there, we apply the principle of homogeneity. It should also be equal to energy, ra. Yeah, it should also be equals to energy. So that means the dimension of energy, what is there? The dimension of energy, re. Tell me, re. mL2 T minus 2 is energy, should be equals to dimension of all of it. So I should say the dimension of B into time divided by T square kada. C is T square, the dimension remains the same. So ekkadi nunchi I'll simply write T square. So this T gets cancelled. So you can simply write this T is in division, send it over, that goes in multiplication. So the dimension of B is coming out as mL2 T minus 1 kada. I got the second answer also. Last, I have to talk about the dimension of A, ra. Cheppandi. Length is in multiplication, send it over there, goes in division. So it is mL2 T minus 2 divided by L is the dimension of A kada. So that is equals to mL T minus 2. Ante. So these are my solutions, re. This is the first, this is the second, and this is the third. Ante. The question is finished. You have to have the idea about it. Hello. Chalo. Next. Multiplication and division of any fundamental quantity can be done. No compulsion at all. No compulsion at all, Sirji. I can multiply. The quantities are there. I can do the multiplication and division of them. Tell me. So this is the formula. I've just taken it for the reference, re. For the reference only, re. Cheppo. I can simply say, sir, force is equals to m into A. So ikkadi nunchi, what can I say about it, re? The dimensional formula is correct. I can find whatever I want. Next, let's move towards the next formula and let's try to discuss. If the energy is given as E is equals to F to the power A, V to the power B, T to the power C, where F is a force, re. You take the normal values, re. F is for force, V is for speed, and T is for time. Ardham cheskondi. I don't have to tell you again and again. F is for force, V for speed, T for time. No. Okay, I did not come to realize that the time is over, Ray. I'm enjoying your chats actually. Yeah, Vaishnavi, you be present in my class, okay? It's interesting things are going on, some interesting things. So we are, discussing some mysterious things in the classroom. We do have some hidden treasures also. Chalo. What should I do, Ray? What should I do? Energy and force ki relationship. How should I find, Ray? I know the dimension formula for energy, kada. What is energy, Ray? Energy is kg meter square per second square. I did it and at least 10-20 times, kada, in session lo. So that is the reason why I remember it. Okay, sir, that should be equals to force ki power A. What is force, Ray? Kg meter per second square, kada, multiplied by velocity to the power b, sir. What is velocity, Ra? Meter per second to the power b into time to the power c, t to the power c. Now what I have to do, sir? I have to take the common terms and I have to equate them. Kani, you see, it is a very lengthy process, kada. You can do it, Ray. You can tell me. Chalo, tell me. It is kg meter square per second square is equals to kg to the power a, kada. It has power a, power b, power c. So it is kg to the power a into meter to the power a, meter to the power b. So meter to the power a plus b multiplication lo untundi kada. And here second square to the power a. So that means second to the power minus 2a into cheppandi here second to the power b kada. So second to the power b and multiplied by t to the power c is there. Now what should I do? What should I do? It is second also. T is second. Cheppandi. So can I simply say kg to the power a mass to the power a plus b second to the power cheppandi b plus c minus 2a kada. B plus c minus 2a. So this is equals to kg meter square. Okay, per second square you can also write s to the power minus 2. Now equate. Kg to the power 1 is equals to a. Meter to the power 2 is equals to a plus b. Minus 2 is equals to b plus c minus 2a. You are getting three different equations, Ray. It is very lengthy process, Ray. What should I do now, Ray? You can go with a shortcut. What's the shortcut, sir? Sir, I know this formula. You see, almost all the space on the blackboard has been gone. But I only need very small space to do this. Chuskondi. Can I say energy is equals to, okay, you observe it. Kg meter square per second square. Kg meter per second square. Only an extra meter is missing, kada. So can I simply say energy is equals to force into extra meter is length. What is length, Ray? What is length? What is the relationship between velocity and length, Ray? What is the relationship between velocity and length? So can I simply say length, velocity is equals to distance upon time, kada. So this length comes as velocity into time. You substitute here f into v into t. Ante. So you can simply say f to the power a. You compare it. So it is equals to f to the power a, v to the power b, and t to the power c. Cheppandi. A key value 1, b key value 1, c key value 1. Ante kada 1, 1, 1 ostundi. Great, very good, mysterious, amazing, good, perfect. Chalo, next. F is equals to t to the power a, p to the power b, v to the power c. What is this p, Ray? What is this p? P is for momentum. Or pressure, you can say. Whatever you want to call, you can say it. You can do it two different ways. Okay, I'm leaving this for your homework. T is for time. P is for pressure. Okkasari pressure tisi. You can take another one as V is for speed. You do it this way also. And then T is for time. P is for momentum. And V is for speed. So this is your homework, Ray. Tomorrow you attempt this, Ray, and tell me, okay? All of you. Next. A dimension of differential and integral terms. So, if at all force is the dimension, cheppandira. Chuskondi ikkada. If at all you have the derivative of something. Chalo. So, what should I write now? What should I write? You can simply say F is force, then dF by dx. So dF by dx ante the dimension of dF is equals to the dimension of force. Ade. And also the dimension of dx, it is also equals to the dimension of displacement. Ante. Similarly, you can end the integration sign, f dx is there. So you can say integral f has the dimension is equals to force and dx has the dimension equals to displacement. Cheppandi ekkadi nunchi what can I say re? So the dimension formula for df by dx is equals to the dimension of force by the dimension of x. Force is mlt minus 2 kada. So it is mlt minus 2 divided by the x. X is length kada. So ll gets cancelled. So it comes out to be mt to the power minus 1. Ekkada kuda cheppandi f dx kada. So integral of f dx, the dimension formula for this is equals to the dimensional formula for f into the dimensional formula for x. Enduku sir, why did you take into? Because here is into re. Okay, so the dimension of f is mlt minus 2 into the dimension of L itself. So what am I getting? What am I getting? ml2 t minus 2. ml2 t minus 2 ra. ml2 t minus 2, ml2 t minus 2, energy. So can I simply say integral f dx is energy also? So this way you can also find the new terms also. Next, okay, 54 limitations are there, and then this session is over. Okay, we are finishing it at a very right time re andariki. Chalo. Let's try to find this question. So I have made this question with very much amount of love into it. Read it. The question says the coefficient of friction is to be found, but we know the force between layers is directly proportional to area. Velocity gradient dv by dx. F is equals to na dv by dx. We use the same n to determine Stokes' law that says force is proportional to n, radius and velocity. Derive the equation. Sirji, it is a very lengthy question. I am not understanding the question itself. Ela ravale the solution, sir. Chuskondi. The coefficient of friction is to be found. We know the force between layers is directly proportional to area. Ante the force is directly proportional to area. Good. Velocity gradient dv by dx. That means f is also directly proportional to dv by dx. Good, Sirji. And this is the formula kada. So directly proportional is there. You combine it becomes a into dv by dx. So a proportionality symbol ni I can change it with f is equals to some constant eta. This is the coefficient of viscosity multiplied by a into dv by dx. Sirji, ekkadi nunchi do I get the dimension for the coefficient of viscosity? Yes, you can get it. Cheppandi. The dimension of force is mlt minus 2 is equals to coefficient of friction ka dimension I don't know. The dimension of area is meter square and L square, I know it. The dimension of dv by dx. dv by dx ante velocity by displacement kada. So velocity ante meter per second, lt minus 1, and the displacement is L itself. So L cancel aitadi. So you are only left with L to the power 2, t to the power minus 1. So ekkadi nunchi what you can say is, cheppandi. So I can say mlt minus 2 is equals to coefficient of friction eta into L2 t minus 1 kada. So L2 t minus 1. Multiply. So you'll simply get coefficient of viscosity is equals to mlt minus 2 divided by L2 t minus 1. Simplify cheskondi. What you will get? I'll write here. Cheppandi andariki. So I can simply say the coefficient of friction eta is equals to m is there, L by L square kada. So I can simply write it ml minus 1 t minus 3. So this is my dimension for coefficient of friction. Good, sir. Now, same n is determined to Stokes' law that says force is proportional to n radius and velocity. We have to find the equation. So that means force is directly proportional to eta, radius, velocity. Let's say the radius is power having A and power B. I have to find the powers only, kada? Chappandi. So here mass is m, L, T minus 2 should be directly proportional to eta. Chappandi, it is m, L minus 1, T minus 3. What should I do, Re? What should I do? What should I do? Chappandi, andariki. Yeah, into radius to the power A, velocity to the power B, kada? Chappandi andariki. Okay, sir, I will try to write the equation now. mlt minus 2, it is directly proportional to ml to the power minus 1, t to the power minus 3 into, you just see, radius ante length kada. So it is length to the power A, velocity meter per second ante lt to the power minus 1 to the power B. Sir, this is minus 1 and this is L, this is L. If I keep the value of A as 1 and B as 1, choose kondi, A as 1, B as 1, it becomes L to the power 1. This becomes power 1. So L into L becomes L square. L square and here L to the power minus 1 is there. It gets cancelled out and it remains L only. So that means power 1 is getting satisfied. So that means, sir G, I'll simply get F is equals to, your F directly proportional to, Chappandi, eta R V. So instead of this directly proportional, you can say F is equals to K into eta into R into V. This is the Stokes' law that you have for syllabus. Chalo. So these are the limitations of dimensional analysis. It cannot give you the dimensionality proportionality constant. See, here also I have taken some random K kada. I don't know exactly the value of K. I know it is 6 pi. Okay, K is 6 pi. We cannot find it only using this formula. The first thing. The second thing, no idea about dimensionless functions sin, cos, tan, e to the power x. For example, I have saying, let's say, F is equals to, or you can simply say, yeah, F is directly proportional to, what should I say, m into a. You cannot say if F is equals to m into a only, or you cannot say F is equals to 2ma, or you cannot say F is equals to sin theta into ma. Endukante the dimension of all three of them are the same. Endukante 2 is not having any dimensions. Sin theta is also not having any dimensions. So this is the second biggest drawback of this. And the last it cannot derive the complete formula adding plus and minus terms. Okay, if at all, do we have one more slide? We will take it. Okay, chalo. So which of the following can be derived using the dimensional formula? So ikkada vachesi, you can say it is distance, sir, but we cannot say if it is plus or minus. Endukante we are trying to determine using this formula. So the dimension of ut plus half at square is same as the dimension of ut minus half at squared. So I cannot say if it is ut plus or ut minus, only by looking at the dimensions. Point number 1. So it cannot be derived. Ekkada kuda plus or minus, I don't know what would it come. So I cannot say here also. Here also observe cheskondi, height is omega square r square upon 2g. Dimension check, you check the dimension, you will getting the same dimension as the distance. Kani, I cannot say if it is omega square r square by 3g or 4g or 5g, all give me the same dimensions. So I cannot say in this case also. The only thing that I can say is velocity is equals to distance by time. So this is the formula I can derive or I can come using dimensional analysis. Ardhamainda andariki? Chalo. Yeah, students, so it was a very good session and time to go now. Okay, chalo, good. How is the Josh andariki? How many of you there? 22 people are there, but the likes is very less, very less. Andariki like cheyandi okkasari. Like the video, all of you. 37 rates, very less rate, 37 likes. Andariki, like it. Chalo. So once we are done, we can end the session, right? Good. So students, Reipu, we will be talking about error and analysis. Okay, so the students who are all present for this lecture, I want all of you to be present for the tomorrow's lecture as well. That would also be starting from the beginning itself. Kani, you have the application of this lecture. So if the students who have not attended today's lecture, I request all of you to attend tomorrow's lecture. But before that, you watch this first. Okay? Good. Chalo. So I think that would be done for us. Yeah. Good night, everybody. Good night, good night, good night. Chalo. So we'll take a goodbye now. And we'll meet tomorrow 6 p.m. 6 p.m. What is the date tomorrow? Friday, right? So Friday we'll be done with 7 p.m. Tomorrow the class will be at 7. Andariki. Hey, Isha. I'll reply you. Don't worry. I'm sorry, Isha. I could not see it. Chalo. Good night, all of you.